Factorisation is a process of simplifying expressions using the laws of algebra, in particular the distributive law. So if we have an expression like this, AB plus AC, so A times B plus A times C, the distributive law in reverse tells us that this is actually A times B plus C. Normally we think of the distributive law as going the other way. A times B plus C gives us AB plus AC. And the idea is that we've taken out a factor of A, this factor of A here. Okay, so this is a relatively simple example, but there are rather complicated examples. So one example might be, let's say, x plus xy. And the idea here is to spot a factor in those two different terms, the x and the xy. Well, x is a factor. And in fact, x plus xy can be written as x times 1 plus x times y. So x is a factor of both of those expressions. And so using the distributive law, we can write that as x times 1 plus y. Imagine this in reverse. I could have got to this expression by expanding out the bracket x times 1 plus y. Well, there are far more complicated examples. So for example, I've got an expression here (9x to the power 5 y squared minus 15 x to the power 3 y to the power 4. So now in this rather complicated expression, we've got two terms. I want to spot a common factor. So what factors have we got? Let's just look at the integers first, the 9 and the 15. There's a factor of 3 in both of these. So I could rewrite this as 3 times 3x to the power 5y squared. So again, expanding out that, 3 times 3 would give me 9x to the 5y squared. Minus, taking a factor of 3 out of this expression, would be 5x to the power 3 y to the power 4. Again, let's go backwards and just check. If I use the distributive law to multiply out this bracket, I do indeed get this. But we're not finished there because there's other factors. In fact, there's an x here in both of these expressions. More than that, we could take out a factor of x to the power 3. Here's x to the power 3. X to the power 3 is contained in this expression as well, because this x to the power 5 is x to the power 3 times x times x. Similarly, y squared is here, and y squared is contained within y to the power 4. So gradually we're bringing out factors, and we've got to make sure what we leave in the bracket now is what remains. And again, just as a check, if you were to use the distributive law properly now, multiplying this expression with each of these, we should get back to this very start here. And you can always check that. Going from this to this should give you exactly the right expression again. There are two other rules that are very useful in factorising. So these are spotting, and these are very tricky to do, but spotting a complete square and understanding the difference of squares. So one example of spotting a square would be x squared plus 2xy plus y squared. Well, this expression doesn't seem to have a common factor in every term. There's no x as a common factor in all three, it's not here, and there's no y as a common factor in all three. But there's a trick here to actually making this rather more simple. This 2 times xy, if I split that up into xy plus xy, okay, 2xy is just xy plus xy. And then think about these two expressions separately, pulling out a common factor of x and a common factor of y. So here there's a factor of x and a factor of x. I pull that out the front here, I get x plus y. Just check. Go back from this stage to this stage and I should get the same thing. Similarly on this side, I can pull a factor of y out. And then I suddenly see there's another common factor in these two expressions. The x plus y is in both of these. So again, I can use that distributive law to give me x plus y, that common factor is multiplied by x and then it's multiplied by y. And now I see that actually my original expression was in fact x plus y all squared. So going from this expression here to this expression here is an extremely useful thing to spot. The second possibility is the difference of squares. And this one really, you can do a similar thing, but this one, it's worth just remembering that the difference of two squared numbers, x squared minus y squared, is in fact x plus y times x minus y. It's a very useful thing just to remember. There is again a way of working this out, but it's simplest just to remember that the difference of two squares is actually the sum of those two numbers multiplied by the difference of those two numbers. So this is the difference of squares. So as well as the distributive law, these two properties of squared numbers are also useful for manipulating expressions.